And welcome to AI plus AR equals superpowers. And this is not a mathematical equation. Augmented reality and artificial intelligence and superpowers, that's what we're going to talk about. So what are these terms? AI, you don't have to think about AI, you don't have to think about, when talking about AI, you don't have to think about stuff like Terminators who are going to kill all humanity, or even Siri or Google Assistant or anybody else. Strictly defined, AI is when machines are displaying signs of intelligence or demonstrating intelligence. So I'm sure many of you have created a small game when I have to think about a number between 1 and 10, and the computer asks me, is it larger than 5? And then I answer yes and no, and slowly the computer will guess the number that I have thought of. And that's AI. It's just a simple set of ifs, but it's artificial, it's intelligence. Now, of course, the more exciting part of AI is part of this. It's called machine learning. And machine learning is when we're not explicitly programming every single decision into the system, but we allow it to learn. We give it data to learn from, and we have some kind of way of verifying that the current state of the learning, where it is. Basically, we grade the machine, or rather it grades himself, and then fine-tunes those little tweaks inside his head, or its head. And the most interesting and really revolutionary part of machine learning is, of course, deep learning. Deep learning is when you have hundreds and hundreds of layers, and each layer can have thousands or tens of thousands of these neurons, which have a tiny bit of resemblance to the biological neuron, and they are connected together. So the artificial neurons just implement a very simple mathematical function, some additions, some multiplications, but they are wired together in a way that as the end result, you get something that we couldn't do a couple of decades ago, or even a decade ago. Something like speech recognition, which we now use all the time on our phones, or image recognition. I show it a picture of an apple, and it tells me that it's an apple. But of course, it has no idea what an apple is. It just knows that the APPLA character sequence belongs to this picture. So that's what I mean when I'm talking about AI. Now let's talk about augmented reality. Augmented reality, my favorite definition is it's an interactive, real-time special effects, or CGI, like what you see in a movie. So here is this handsome fellow, and you can see that this is a real-time application on iOS, and my body has been redrawn with basically something that looks like a pencil sketch. So this is AR. And of course, this is AR when there's obviously not a single stormtrooper on this field, but still, through the phone's camera, you can see that. And these stormtroopers are like they were in the actual scene. But of course, we can use AR for much more useful stuff, such as navigation. This is Google's AR navigation, walking directions. You have these huge arrows sticking out from, not even from the ground, they're levitating, and they show you where to turn, so you know you don't get lost. Or you can use AR to do stuff like measuring. This is an awesome superpower of just looking at something and knowing how big it is, and all you need is a $1,000 phone instead of a $2 measuring tape. And it's also not as precise, but, you know, whatever. This is AR. And of course, this is AR as well. And this is the most popular form of AR when I have the superpower of changing myself into somebody else or some other something. And this is actually a very lucrative form of AR. With Instagram and Snapchat filters, they're actually making serious money through advertisement using these. But the kind of AR I'm most excited about is when you're having an AR headset. And how many of you have experienced an AR headset before? Okay, so that's about half the people here. AR headsets are very different from this mobile AR that I just showed you, because they have this transparent glass which projects light into your eyes. So you can see the real world, just like I can see you now, except for all of those lights. And you can see the artificially generated images. And because we have two eyes and it has two image generators or image projectors, and it also knows how I move in three-dimensional space, that means that it can calculate that as I move from that point of view, for example, if I wanted to have a virtual vase on this table, it could calculate what pixels it has to project into both of my eyes so that I can have a virtual vase. And the illusion is pretty good. It's far from perfect. I'm not saying that, but it's pretty good. So I have the ability to magically conquer, not conquer. I don't know the word. Anyway, magically make it appear that there is a vase here, and anybody who's wearing that glasses will have some kind of belief on that. So that's what I'm most excited about. And when talking about superpowers, I'm not going to give you the superpower of lifting cars. I'm sorry. Yeah, I know. Or, you know, the superpower of flight, which is also something that I can't do with AI and AR. And I also can't give you the superpower, the ultimate superpower of all, billions and billions of dollars. But I can give you the superpower of magic. And it's not just magic, it's actually going to be useful magic. And because this is not a magic show, I asked, I'm going to explain how some of these magic tricks that I'm going to show you are actually created, so that hopefully I can give you something. So let's see what kind of magic we're talking about. Here is example number 1. I'm wearing a magic leap in this, by the way. And you can see that I could just conjure up a cube like that. And you know that it's a real cube because it lights up my hand. Well, okay. It's a pulsating cube light. And I can bring up another one. And then I have a red cube and a blue cube, and they look pretty real to me. I mean, I know they are not real, but they are there in 3 dimensions when I'm wearing this glass. And I can just move my hand around them and, you know, make them disappear when I had enough. So this is cool, right? But the similar technique can be used to do something a little bit more useful, like conjuring up an iPhone. And this iPhone weighs 0 grams. I bet that Tim Cook won't be able to reach that soon. And it can levitate and it stays in place. And I can actually grab my finger and press some of the buttons. So, and then make it disappear when I no longer need it. So how do you think I did this? Nobody? Okay, so the way I did this is that I had a 3D model of an iPhone, of course, and Magic Leap has hand recognition and gesture recognition. So basically, when it recognizes an open palm, it will put the iPhone model over there. When it recognizes a closed palm, it will make the iPhone model disappear. Pretty easy. And as for pressing the button, I recorded a small video on an iPhone of me pressing the weather applications button. And when I did this with one of my hands, I pressed the button on the controller on the other one, so that started playing the video. It's not so magical after I explain it, but I think it's interesting. This is another favorite magic trick of mine. This I call hand throwing, but you may have seen something similar in Star Wars movies. So what's going to happen is, here's my hand, and I'm going to concentrate, and there's another hand of mine, and I can actually manipulate physical objects with it. So how was this word? How was this created? Yeah? We didn't know. Close. This was created with the help of my lovely wife. So this is the work film. And we should have some audio. Maybe it's my problem. Anyway. So yeah, that's how it was created. I counted 1, 2, 3, and then she did the physical stuff. So that's fun. Going on. The same hand throwing technique can actually be used to operate switches in your smart home. So like this. I said like this. Play button. Here we go. I perform the same throwing gesture. For some reason it's very slow now. And then it turns on the light. It should be much faster, I'm sorry. That's PowerPoint. And then I do it again and it doesn't work. And then I do it again and it doesn't work. And then on the third try, finally it works again, so then I can switch it off. So why didn't it work? I didn't create a commercially adaptable gesture recognition system. All I did was I created a small application that tracked the speed of my hand. And I said, when the speed reaches a certain threshold and then it stops, that's when the gesture is triggered. Now, this is very error-prone. This is fine for a video, but in real life, when you're doing stuff like this, it had tons of false positives and false negatives and everything like that. So in real life, what I would do is invoke, next to AR, I would invoke AI, and I would turn a small neural networks on hundreds and hundreds of these samples from different people, and then it would probably be much more reliable. Speaking of this experiment, I just can't let it go. But why do we need switches anymore? If we have this, we have this power of just throwing the hand, now we can just tap the actual light instead of the switch. So that's like the difference between using a mouse to click a button versus pressing a button on a touch screen. Okay, enough of that. So all of this is fun, but what I'm enthusiastic about when it comes to AR and this kind of headset ARs is when we're not just augmenting reality, we're also augmenting humans. We're also augmenting ourselves, our brains, our cognitive functions. And this is a great example of that. She's in an industry, she's in a factory, and she's learning how to put together an engine. And she has written text floating in front of her so that both of her hands are free. And she also has these nice handy arrows that point to where she has to put that fuel regulator or whatever. And that saves a lot of time. And learning in the industry like this, or with VR, with similar techniques, has an extremely high return of investment, like hundreds and hundreds of %, a very high retention rate, and an accelerated learning, which is very important today. This is a project that we're working on at the company called Arinex. And the idea here, again, is to augment people, to augment the condition. So we are helping aircraft engineers to analyze and catalog aircraft defects. I don't know about you, but I really would like to fly home safe. And one of the ways I can be fairly sure that will happen is because what happens is that the airplanes are routinely inspected. Every square centimeter is inspected, and every single dent or lightning strike or whatnot is categorized and analyzed whether they are safe for flight or whether they have to be fixed first. every single dent. And this is a very manual process, and this is also a process that requires a lot of paperwork, a lot of human writing and reading, and there's an 18,000 page manual for every aircraft that you have to be up to date on to decide whether a damage is something that you can allow the plane to fly. So what we're doing and what he's seeing when he's putting on this headset is this grid on the airplane and the existing damages, but however small. And then he can select the damage, and he has every data for that damage right next to him. And we have a 40 to 60 meter plane, and we can position these damages with a few millimeters of precision, which is pretty cool. And this is required so that you can make the decision. Another favorite puzzle of mine is the Rubik's Cube. How many of you know what a Rubik's Cube is? That's pretty much everybody. How many of you can solve the Rubik's Cube? Yeah, that's usually about 5% of the population. And how many of you know how to solve the Rubik's Cube because you figured out yourself without any external help? You? That's awesome. They say that there's about 500 people like you who can just figure it out. But anyway, I couldn't and I can't, and a lot of us can't. But Rubik's Cube and it's such a hard puzzle because it has something like 43 quintillion different states, and only one of those are considered to be solved. And you know that 43 quintillion is a pretty big number because different combinations has a lot of letter, and that's still wider than that. So I'm fascinated by how AR can help solve these challenges. And another similarly difficult problem is setting the time on the microwave, which happens twice a year, you know, daylight savings and all that. And it's almost the same difficulty because how would you set the time on this one? Just with these controls. The way you set it is you set the strength to vertical, and then with this thing, you rotate it counterclockwise if the door is closed, 360. And then it gets into time setting mode. And I know this because I've done it a lot of times, but the first 5 years, twice every year, I had to bring out the manual. So what if I could just put on a smart glasses and I would see the same arrows in a somewhat better representation, but the same kind of idea. Oh, that's how you set it, or with your alarm system or whatnot. Similar like the Rubik's Cube. So I figured that if I could solve this Rubik's Cube problem of mine, then I would be able to give a good example. And my idea was to have this Rubik's Cube. And for example, if we need to turn it that way, then I would have a three-dimensional arrow rotating that way. That's the idea. So I got to work, and this was last year. I knew absolutely nothing about computer vision and neural networks. You can testify that I used to call these technologies black magic. But I wanted to solve this, so I started to learn, and this is where I got last summer. So this is called object detection, and the computer vision can detect the cube even in a scrambled state, as you can see, and draw a little rectangle around it. So I figured that would be the first step. So how did I get here? Well, I watched a couple of videos, got a general understanding, but this book is the one that actually put me over the edge, and this book is the one that helped me really understand how machine learning and deep neural networks and computer vision worked. So it taught me that when the computer says that this is a mouse, that's called image classification. When the computer says that this is a keyboard and this is a mouse and draws these little rectangles around them. That's object detection. So now I at least had a terminology to search for. And I knew that object detection would only work if I had a varying set of images. So I went on to Bing and downloaded 700 images with the word beautiful, because I figured that I would look at these images a lot, so at least they should be aesthetically pleasing. And I downloaded all of these images, as you can see, and I got stuff like, I don't know, a beautiful glass butterfly, or a beautiful person, or a beautiful landscape, all of these. So then I went to Unity, and I created, this has disappeared, I created an application that would allow me to randomly place and rotate a Rubik's Cube. So this would be my test data, the input data for the neural network. And I got this lovely cube cube model, 3D model from a friend of mine, and I created a couple of scripts. A script that's a cube randomizer that would rotate it randomly and move it and scale it randomly. A screen recorder, which output basically screenshots of every such random thing, and the label generator, which outputs labels. So I got to start this application, and I slowed it down for you a little bit, because if anybody has epileptic seizures, I don't want you to get it right now, because it was really fast. But you can see on the left the layout of the scene, and you can see on the right, this is the image that has been generated. And I generated 5,000 of these. Why not? I had no idea what was the right number. Maybe it's 50, maybe it's more, I don't know. 5,000 sounded like a good idea. So on the left, you can see the test images generated, and on the right, you can see the data. So for every single image, there's one row, and there's these four numbers, which contain the X, Y, Z, width, and so on coordinates of the bounding rectangle. And then I went to work. I wrote some Python. I used some code from the previously mentioned book, and I started to train this neural network. And there's something called meta-parameters, which are basically parameters that control how the training works. And that's an art form that I didn't have yet. So after about 20, 30 tries, I managed to get to this stage that you saw before. But what's interesting about this is I have never taught the neural network how to identify a scrambled cube. All of my examples were solved cubes. And still, it managed to do this. So I have no idea why it can work with a scrambled cube. My guess is that it's probably gotten to learn about these dark grids, but that's just my guess. And I just learned from Fiona before, in an earlier talk, that there are ways to track this down. But still, a lot of people in the industry have no idea how the neural networks work. And that's a whole research area. So that can be pretty dangerous, where AI is used for stuff like deciding how long a prison sentence should be. That's, again, an example that you brought up, but I had it first. And how long a prison sentence should be based on how likely this person is to commit the crime again. And then it turned out that the system was racially biased. So people's lives were decided by the system. That's pretty scary, isn't it? Okay, so back to the Rubik's Cube. Last year I showed this video. Oh, we don't have sound, anyway. So as you can see, basically I managed to do what I set out. I'm solving the Rubik's Cube solely based on the suggestions of my HoloLens, which is an augmented reality glass. I have the glasses on, I have the Rubik's Cube in front of me, and I see the arrows, and I'm rotating them, and it's awesome. Now you can see that it's real because I have a lot of debug info right there on the side. So I was really happy with this, but again, this is a session where I'm not showing you magic tricks. I'm telling you how I did this. So, anybody has any idea how I did this? Not you. You know it. Nobody. So, this was the key. This frame from the video. I was using a special cube that had Bluetooth in it. And every time I turn the cube, it sends a little Bluetooth message to my HoloLens so that I know that the cube has been turned and I can calculate the next step. So that's how I did it. Now, I know that there are some extremely talented computer visionists who can do this with any special cube. I'm not one of them, and I was perfectly happy to get to here. So again, I managed to solve a problem which is almost as difficult as setting the timer, the time on a microwave, using augmented reality and a little bit of AI. Okay, I'm going to skip this. Have you seen this movie? This is a short movie called Sight. It's 7 years old. Nobody? You have. Awesome. This short movie is taking us to a future where everybody has augmented reality contact lenses. And these augmented reality contact lenses have full spatial awareness. They know where you are, they know what you're looking at, and everything else. And I'm not going to spoil it, you got to watch it, but there's one scene in it when the protagonist goes on a date. And this is what he sees. He sees how likely this girl, how much she likes him. He sees stuff like hobbies. He sees stuff like his social wall, like future Twitter feed or something. And I thought about, wow, this would be very useful for me. Not for dating, but for everyday social interactions. Just yesterday, we had a speaker's dinner. But before that, I met with another speaker and we went for lunch. And then we had a speaker's dinner a few hours later. And the guy I spent 2 hours in my day with, I introduced myself again. Because my face memory is just so freaking horrible. I had no idea in that social situation that it was the same guy that I just spent lunch with. So imagine that I would be able to just look at him and, oh yeah, you were that guy. So I set out to build this. And the application I wanted to build is to have facial recognition for every single person that I follow on Twitter. And to do that, the first step, you have to apply for Twitter Developer Access, and this was a surprisingly painless thing. And then I downloaded all of the people I follow on Twitter. Well, not the people, but a little bit of their data with this tool called Link to Twitter. And then I got this. This is a list of people I follow on Twitter, at least the few 30 of them. And for every person, I got something like their ID, Twitter ID, their Twitter name, and an URL that tells me where their profile picture can be downloaded from. All of this is public data. So then I, of course, created another application, and I downloaded all of the profile pictures of the 1,200 people that I follow. And you can see that everybody has different kind of pictures. So this guy has a perfectly normal picture. He also has a perfectly normal picture, but it's really not his. And this picture, okay. Some people have these cartoony pictures, and because I work on work a lot and follow a lot of people with AR, VR affiliations, a couple of people even have AR, VR glasses on them. So, okay, this is what we're working with. One picture per person. And then I uploaded these pictures to Azure Cognitive Services. And I'm not going to bore you with all the code. I had to decide whether to go with a free or paid tier, but I figured that you guys were worth it for me. So, yeah, let's go with the paid. Also, I didn't want things to just break down right here at the demo. And it cost me so far something like 3 or 4 euros. So you guys are worth all of that. And then I uploaded all of the images before to Azure Cognitive Services. The only interesting part is this, when I actually uploaded an additional user data. So that would be the Twitter ID of the person, so that I had some connections between the two. So the upload went semi-successfully. I got a lot of fails, and these are for people whose profile image is not really of a human, or not something that the face API can work with. But I got a lot of successes, and totally unrelated, but I think it's interesting. There's about 50% of people among those I follow who have a decent profile picture versus those who don't have a face. So, okay, I got a chance to recognize people, at least 50% of the people that I follow on social media. That's way better than what I do by myself, so that's good. And then I did the training. I wrote a little application or a little routine that would poll the server every time, every second, so that I would know when the training is done. And then I ran this. And the training actually took 0.7 seconds. So all of that was unnecessary. But then I read forward, and it turns out that if you train 1 million people, then it's still done in about half an hour, which is pretty awesome. Both of those things, 1 million people and the half-hour thing. So then I created the app. And the way the application works is that I first run a local face detection. So just on the computer, a face detection. Is there any face on a picture? And the reason I did this was that if I accidentally leave the computer on, and it starts sending the picture of my wall to the cloud many times a second to see who is there, that's going to cost me a lot. So first I do a local face detection, and if there's no faces, we just don't go on. And then I have to send it to the Azure cloud and call another face detection there. You can't call the face identification directly because I don't know why. But the second step gets me back an ID, which I feed back to the third step, the actual face identification. And if there is something that I can actually show, then I open up a web browser and show the Twitter feed of that person. So this is how it works in theory. Let's see how it works in practice. It takes a little time to boot up. There we go. Okay. And I'm going to show it a couple of pictures. So this is my friend, fellow MVP, Jessica Engström. And you can see this is how quick it was. High confidence, 0.91%. This is you can see the picture there. That's her profile picture, and you can see the Twitter feed on the right. Okay, that was easy. Even I could have done this. So the next MVP friend of mine, Mr. Gianpaolo. And Okay, so the thing is, the phone is reflecting Jessica's face. And that's what it was catching up on. Oh, the screen, yeah. Thank you. Not the phone, the screen. You can't prepare for everything. Thank you. So yeah, look at this. It's the same guy, obviously, but the profile picture, he wears sunglasses. His eyes are not even visible. And he partially occludes his face with his fingers, but still, 86, 88% confidence. So here's another guy. Come up here. Because I got a picture of you, but it's much better live. Yeah. This is Dennis. And there you go.
Without glasses even.
And you can see, again, how different his profile picture is from the actual picture that you see. Thank you. Thank you. Because this is very similar to what you look like now, what the profile picture is now. And here is this this last picture. This is of Alex Kipman, who is the inventor of HoloLens. Now, in the profile picture, he has a beard, he has a mustache, he has a HoloLens in front of his face, and still we are talking about 67, 69% probability, and way less than 1 second response time. And all of this from just one picture for every single person. So that's freaking amazing. And also freaking scary. Right? That's how technology is today. Both amazing and both scary. And this is important because we are at the point in history when we are making decisions that will influence how this tech is going to go forward. We are affecting the future in a way that no, let's say, layman could do before. So we have a great power and to create something that's hopefully uplifting, that's hopefully something that people will, that will enrich people's lives and not the other way around. And we have a great power to do that. And as you know, with great power comes great responsibility, speaking of superpowers. You know, this is what Spider-Man's uncle said. Wrong. This is what this thought actually originated from the French Revolution. But whatever, it's still valid. So that's what we have to do. Be careful of how we use these amazing technologies. I'm András Velvárt, and I give people superpowers. Thank you.